we have 4 integrals on the board. And the number 1 is the integral of square root of psi x. Number 2 is square root of sinx x. Number 3 is square root of psi x plus 1. Number 4 is square root of sinx x plus 1. And which one do you think? And there are 4 integrals and only one of them is elementary integral. And which one do you think is the only one that can be integrated in elementary functions? First, I'm going to reject 2 integrals. These 2 integrals cannot be integrated. Square root of psi x, wherever square root of psi x, square root of sinx x, it cannot be integrated in elementary function. And what about this? Square root of psi x plus 1. And number 4 is square root of sinx x plus 1. The fact is that the integral of square root of sinx x plus 1 does not have the answers, and only one that have the answers is square root of psi x plus 1. Why? Why the integral of square root of psi x does not have the answers, but square root of psi x plus 1 does? So let me do some step like that. The integral of square root of psi x plus 1 is equal to, let me just multiply with the conjugate, psi x plus 1 multiplied by psi x minus 1 and then multiply by psi x minus 1 like that. So over this is just equal to this is square root of psi x minus 1 like that. And then here is the deal. Psi x plus 1 times psi x minus 1, you just get psi square x minus 1. Psi square x minus 1, but we have a negative. Don't do that. Let me just switch the order. Don't multiply by this. Multiply by 1 minus psi x. You will be good. Psi x plus 1 multiplied by 1 minus psi x. Then you will not get the negative, right? 1 minus psi x. Yes. Because we are inside the square root. We don't want an imaginary number. So square root of 1 minus psi x this. At the top you just get 1 minus psi x times 1 plus psi x. So this square root, and this just goes out square x, right? Take square root, you get cos x. And then here's the deal, we can just use up. Let me just let u is equal to the entire thing. Entire u is equal to 1 minus psi x and take square root, and then do the derivative, you get du is equal to, first you get 2 times 1 minus psi x, and then multiply by the derivative of inside again, negative cos x dx. So over, put 2 into it. So this one is just equal to put a 2 here and then multiply by negative on both sides. So this cos x over square root of 1 minus psi x dx is just equal to negative 2u du. So for this is just equal to negative 2. Be sure, no, just negative 2 here. We don't have a u. Be careful. Finally, integrate 1 in our u row, you just get u. And then change to our x row, you get psi x plus 1 plus c. And that's it. That's the answers. And why this does not have the answers, just check the Wolfram alpha. Or I will do some step here. Sinx x plus 1 dx. Let me just multiply with the conjugate. Multiply with the conjugate once again. Let me just do this really quick. Plus 1, take square root this. You pretty much just multiply by 1 minus sinx x, right? on both the numerator and denominator. So this is just 1 minus sinch square x. However, this is hyperbolic sine, and 1 minus sinch square x is not equal to cos x, cos square x. So because the hyperbolic, the identity cos square x minus sinch square x is equal to 1. So 1 plus sin square x is equal to cos square x and not minus. So we can get rid of this. So this it looks really impossible. So this cannot be integrated. So how can we make it to be integratable? I don't think so. Even if it's a negative, if this is a negative sign and then multiply by 1 plus sin x, you're still gonna get 1 minus sin square x here. So never mind, just whether this plus or minus, they don't have the answers.